understand electricity, guys, we need to know some basic concepts. What is charge? What is current? What is potential difference? What is resistance? And what is power? If you know what are all these, what are the units, and what are the formulas, everything will be covered in it, right? So, what is charge? Charge is a fundamental property. Presence of electrons give us charge, and it is measured in what? And indicated by Q. Next very important part is current. Movement of electrons, movement of charge is generally current, and it's measured in amperes, right? Instrument used for it is ampere, right? And we designate it by I. So I, the formula is Q by T. If I ask you how much is 1 ampere, you will say 1 ampere is 1 second. Now there are different amperes. You have milliampere, you have microampere, you have kiloampere, you have megaampere. You know it? Milliampere is 10 to the power of minus 3 ampere. Microampere is 10 to the power of 17 ampere. Kiloampere is 10 to the power of 3 ampere. Right? Mega 10 to the power of 6 ampere. If I asked you in the problem, I gave for example 25 milliamperes, convert it into amperes. 10 to the power of minus 3 means, I hope you know the mass, 1 by 1000. So if I gave 25 milliamperes, 25 by 1000, how much? 0.025 amperes. So you should know those basic conversions. Next very important thing after knowing the charge and current is potential difference. Potential difference. Potential difference is work done or energy required or potential required to move a unit charge from one point to other point. It's work done or energy required or potential required to move a unit charge from one point to other point. Potential difference is measured in volts, and equipment used is voltmeter. So according to the definition, V is equal to work done W by Q. If I ask you how much is 1 volt, 1 volt is 1 joule, because joule is the unit for work done, by 1 coulomb. Right? Next, very important is resistance. It's an opposition to flow of charge. Resistor means it's not a separate device. Every electronic equipment, every utensil, every gadget you use will show resistance. An electric bulb, an heater, an air conditioner, a normal conductor wire, everything will show the resistance. So every wire, every conductor, every device will show resistance. Resistance is opposition to flow of electrons. Okay, it's an innate property of material. It changes from material to material. We will see what are the factors which affect resistance and its formula also. So according to Ohm's law, we will get the formula resistance is equal to V by I. And what is Ohm's law? Ohm's law is the relation between potential difference and current, and it is measured in ohms. Equipment used is ohm meter, and the signal is Greek letter ohm. Okay, with this formula you have many problems, right? We can write V, voltage is equal to current into
resistance.
Resistance, right? And current I is equal to V by R, right? So these formulas are important. Next, what do we have after resistance? Power. Power is measured in watts. Capital W is its symbol, and P is equal to V into I. This is the formula which we are going to use. If they ask voltage, then if they ask current, then what will be the formula?
P by V.
P by V. Okay. Next, heat generated, energy produced, H is equal to I square R. This is the formula. This is also called as Joule's law of heating, right? So heat generated is directly proportional to square of the current. Heat generated is directly proportional to the resistance. The more resistance, somebody asked about this one. The more resistance the coil shows, the more heat is generated, and heat is directly proportional to the time, right? through which you have sent the current. So if you know these formulas, you can do anything. One more formula which is missing is factors affecting the resistance. R is L by A. So resistance is directly proportional to the length of the conductor. If length increases, resistance increases. Let me explain. You see, if this is a one wire and this is the wire. If this is a road, a lane in which your vehicle is going. So if lane is thin, traffic will be more, you will be slower. If lane is double line, triple line, what will happen? You can move easily. So the more thicker the wire, the less will be the resistance. And coming to length, the more bigger, the more length your conductor have, the more resistance it will have. That's why you will see in heater coils, you have like this, to increase the length. If length increases, resistance increases. If resistance increases, heat produced can be increased. You see in hair dryer, you have a coil of wire. So we coil it so that resistance increases. So on this you have some problems. I will give a simple one which will help you in today's exam. So I hope you will understand it. So if a length of wire is given as L, length of wire, can you see the board?
Yes, sir.
Length of wire is given L, area of cross section is A, area of cross section is thickness, and resistance given as example 10 ohms. Resistance given as 10 ohms. Then if I take the same material and reduce the length to L by 4, means 1/4. See, if this is the wire, now I took fourth part, 1/4, and increase the area of thickness 2.5 times A. 2.5 times A. Now I am asking you, what will be the resistance? How you will do? What is the formula? R1 here is rho L by A is equal to 10 ohms. So R2 is equal to same formula, rho L, L is L by 4 by A is 2.5. 1 by 4 into 2.5. 1 by 10. Rho L by A is 1 by 10. That is R2 is 1 by 10 times of R1. How much is R1 given? 10. So 1 by 10 into 10 you will get 1 ohm. So using this formula, you can calculate resistivity. Here we are not calculating resistivity because he is saying same material. So resistivity will not change. If there is resistivity also, you can change the formula. R rho is equal to RA by L. Right? So that is the basic formula which we are going to use. Now, where we are going to use this kind of formula? One thing which was missing is connecting resistors in series and parallel. I hope you know. Example. Do you know about this circuit? See. There is a battery here. Let's take 12 volts. There is a key here. An ammeter connected here. It's 3 ohms, 3 ohms, 3 ohms, 3 ohms. R1, R2, R3, R4 and R5. They'll ask total resistance or combined resistance. They'll ask current, total current. How you will do? First, you will take these two, R2 and R3. They both are in series. You will add them. R2 plus R3. You will get 3 plus 3. So now I will change the circuit. See. I just start.
स्टार्ट कर दिया सर
I will change the circuit here because I have mixed this both. So now it will become like this. Now this will become 6 ohms. The total of R2 and R3 I am giving this name R dash. So R1, R4 and R5 are there. Now R dash and R4 are parallel. So I will take them. Right? So resistance in parallel is equal to 1 by R dash plus 1 by R4. So 1 by 6 plus 1 by 3. I will get 2 ohms. Now I will displace this with a 2 ohm resistor. So now 3 ohms, 2 ohms, 3 ohms resistor. Now you see 3, 2 and 3 all 3 are in series. So R1 plus now R double dash, right? Combination of these 3 and R5. What is the total resistance? R1 plus R double dash plus R5. That is 3 plus 2 plus 3, 8 ohms. So what will be the current? R is equal to V by I. I is equal to V by R. How much is voltage? 12 volts. By what will be the current? What will be resistance? 8 ohms. 12 by 8. Amperes. Units are very important. This is the way how you will calculate and how you will use all these formulae. Wherever they give, whatever they give, you should be able to calculate. Okay? Let me give one more small problem on power calculation. Then we'll try to stop. Then I'll take your doubts. Let's take a circuit. Connecting in series and parallel are very important, Anna. So let's take 4 bulbs here. So one bulb is here, second bulb, third bulb, and fourth bulb. Let's take potential difference as 12 volts. There is an ammeter also connected here, right? This bulb is using 3 amperes current. This bulb is using 4 amperes current. This bulb is using 5 amperes current. This bulb is using 6 amperes current. So this is an example in case study. They will ask number 1. How these bulbs are connected in series or parallel? No. See, current is not same current, it's distributed. I1, I2, I3, I4, 3 amperes, 4 amperes, 5 amperes, 6 amperes, different current. It means they are in parallel. So now, second question, if they are in parallel, what are the uses? Why we connect them in parallel? What happens if we connect in series?
If one fails, there is no chance of other to.
Yeah, if we connect in series, if one bulb fails, all other will fail. If you connect in parallel, if this bulb fails, no problem, current will flow to the next bulb. If this bulb fails, no problem, current will flow in the first bulb, third bulb, then fourth bulb. No issues. So we connect in parallel because of 2 reasons. One, if one bulb fails, others will work. Number 2, equal current may be distributed, right? Goes from battery to the all other sources. Okay? That's the important thing. Third thing, he'll ask, which bulb will glow more? Which bulb will glow more? Prove it with calculation. So power is equal to voltage into current, right? And here it's a bulb we are connecting, so 120 volts power will be there. Voltage into current. So we have P1, P2, P3, P4. P1 is the power of the first bulb, P2 second bulb, third bulb and fourth. So P1, P2, P3, P4. P1 is voltage 120 into 3 amperes. P2 voltage 120 into 4 amperes. 120 into 5 amperes. 120 into 6 amperes. Chalo, 120 into 3.
360. 480. 600. 720.
Sorry. Here is 120 into again 3 amperes. This. How much again? 360. Which have more power? Bulb C. With 5 amperes will glow more. Right? So this is the way how they are going to ask the question. You need to able to use the formula and you need to able to calculate. Okay? Now I will give one